Yes. Hola. So, question number 1. We have the equation of a circle, and we can already see that the center is not the center is not the origin. Yes, the center is not the origin. Cool. Then they say show that the point P, it lies on the circle. So basically you're going to substitute this point on X and Y, and if we don't get 15, it doesn't lie on the circle, but if we get 15, it lies on the circle. So you'd say okay, you have so you have so you have 2 squared plus minus 9 squared minus 8 into 2 plus 6 into minus 9. We get 2 squared, which is 4, plus 9 squared, which is 81, minus 8 times 2, then minus 6 times 9. I'm getting 15. So therefore P lies on the circle, right? And then they determine the equation of a tangent. So determine the equation of the tangent. So now you're gonna find the center because you need it, right? So to find the center, you say x squared plus x squared minus 8x plus y squared plus 6y equals to 15. X squared minus 8x, we take 8 divided by 2, you get 4. So therefore you will say plus 4 squared minus 4 squared. Then we come to y squared plus 6y, right? Then we take the number 6 divided by 2, we get 3. Therefore you have 3 squared minus 3 squared. Then you still have your 15. Group the first 3 terms in each. Therefore you have x minus, there is a negative, minus 4 squared, then minus 16, plus you have y plus 3 squared minus 9 equals to 15. So this is 25. So this side you're going to have, this side you're going to have 25 plus 15, and x minus 4 squared, x minus 4 squared plus y plus 3, x minus 4 squared plus y, yes, and of course here you have 30, 40, you have 40 here, and and you have x minus 4 squared plus y plus 3 squared, and therefore the center is 4 and minus 3, right? So you're gonna find the gradient of your radius, remember your radius is from the center to the circumference, which is point P. So you're gonna say y1 minus y2 over x1 minus x2. Therefore you have minus 3 minus 9 minus 9, right? You have 4 minus 2 equals to, this is going to be positive 9, so it's 9 minus 3, which is 6, and then here you have 2, and then you have 3, right? And then you say gradient of the radius multiplied by the gradient of the tangent is equals to -1. You have 3 multiplied by mt minus 1, and therefore t is going to be -1/3, right? You say y into x minus x1, and substitution. You have y minus the point, remember, -9, right? And then gradient 1/3 into x minus 2. Is it 2? Yes, it is. Right. And you have y plus 9. You have -1/3 x plus 2/3. And then of course the 9 comes inside as a -9, right? And therefore you're going to have y equals to -1/3 x minus, and that is 27/3, so 27, that is 25/3. Let me see, 2/3 minus 9. Damn, I'm good. Sure. So this is the equation of the tangent. Let's see. They were like, determine the equation of the tangent. Oh yeah, so this is all your 6 marks, bro. This is always 6 marks. So they say, so here's the question. A tangent is drawn from Q to the circle. Calculate that length of the tangent. This question was not clear, right? Or perhaps initially when I read it, I'm like, what are you talking about? Like, are you saying the tangent we spoke about in 4.1.2, right? That tangent at P, right? Or what are you saying, right? But since now, like, they didn't mention anything about a P, right? Let's do it this way. Let's do it this way. So you have, this is of course the equation of the circle, the center, and the equation of the tangent. We will not need this one, right? So you can just draw a rough sketch where you have your circle and the center, just a rough sketch, right? And for this one, it doesn't really matter because we do not know where the tangent is at. So you can make your tangent to be this side, or alternatively you can make a tangent to be this side. So then you would have something like this. Then you'd have something like this, right? Can move it there we go. Then you can have something like this, right, to realize that, oh, you have a tangent here, right? It wouldn't make any difference here since they already told us that, yeah, like they didn't say anything else. So the diagram is just for illustration or just to help you visualize your calculations. Cool. So you have your radius here, and the tangent and the radius are perpendicular. The point here is the point here, what is the point? It's 4 minus 3, right? We can try to find the distance for this. So let me call my center to be O. So then I will say QO. Distance for QO is gonna be YQ minus YO squared plus, this seems like 2, plus XQ minus xo squared. So yq is 12, I believe. 12 minus 3 plus minus 10 minus 4, right? So 12 minus, it's gonna be plus 3 plus, it's gonna be 14 here, so 14 squared, right? You get square root of 421, ne? And you know that your radius is what? The radius is square root of 40, right? So now we have the distance for this, we have the distance for this. We can say, let's call my point T. So we can then say qt squared plus radius squared equals to hypotenuse, which is qo squared, right? This is what I'm going to use. I have my hypotenuse to be 421 squared, my radius to be 40 squared, and then qt squared, which is qt is what I'm looking for. So I will make some space. Here I'm gonna have qt equals to 421 minus 40 equals to 421 minus 40, 381, right? This is a squared, and therefore qt is gonna be square root of 381, yeah, which is just square root of 381. And there, right there, you've answered the question of what the distance is, right? But I figured, because the question was kind of like a tricky, I don't know, perhaps it's English that was tricky about it, because at first you would wonder, are they saying there's a point called Q, and that point, it moves from Q, like wherever Q is, to P, because remember P, right, there's an equation of the line at P, right? So it moves from Q to P. So I have a line called QP forming a tangent to my circle, and then you would try to find the length of PQ, which you can use the distance formula to simplify the distance. You would wonder, I was like, will I do it like this, right? But also, I think when you think of technicalities, this is 4 marks. For distance formula at grade 12, I'll just give you 2 marks. So I don't know, but yeah, hopefully when they set the exams, they become more clearer as to what is it that they expect from you. But otherwise, let's move on. You have a circle there. So the circle with the center T, right? The circle with the center T is given below, and B is the y-intercept of the circle. Cool. So from here, you already know that this point is what? T is going to be 3 and minus 2. But they like determine the B coordinate. B, which is y-intercept. Y-int x equals to 0. So you take your equation 0 minus 3 squared, y plus 2 squared equals to 25. And then you're going to have y squared plus, you have 2, then 4. 4y, then plus 4, and then plus 9 minus 25 equals to 0. You have y squared plus 4y. Then you have 4 plus 9 minus 4 plus 9 minus 25. You have minus 12. Right? Equals to 0. Let me see. Yes. Then you have y plus 6 into y minus 2 equals to 0. And therefore y equals to minus 6, or y equals to 2, right? So you have a y here of 0 and minus 6. Therefore b is gonna be 0 and 2. These are the coordinates of b. Then they write down the coordinates of c if c is the reflection of b in the line y equals to 3. So you see this line, let me take red. Oh, come on, what are you doing, bro? So we draw a straight line. Come on, bro. Don't disappoint. Hey, bro. Cool. Yeah, that was perfect. So they say now we have that straight line. If you're aware, that line, it divides our circle into 2 equal sides. They write down the coordinates of c if c is a reflection of b along the line y equals, so that means here we're gonna have what? The same value of what? The same value of y, right? So you know therefore that c, we'll talk about x values, but you know your y value is gonna be 2, right? Yes, it's gonna be 2. And now if from here, from b, which is at x equals to 0 to t, you had 3 units, that means there will be 3 units from t, from this line to c, and meaning that that point will be 6, right? So yeah, this one is not basically like any calculation of some sort. Yeah, because from here to here it's 3 units, therefore from here to here it's going to be 3 units, making from here to here to be 6. Cool. Another circle with center M and the equation, right? We already know what center M is. It's of course 12. So M is 12 and 10, right? So it's given. They'll calculate the distance TM, right? So this is M, this is T, which is 3 minus 2, and so for this one, distance for TM, you see exactly what I meant. They gave it 2 marks for distance formula. So yeah, this would be YT minus YM squared plus XT minus XM. Then you have, what do you have? YT, that is minus 2 minus, oh, this is T, cool, minus YM, which is 10 squared plus 3 minus 12 squared, right? Then the answer is, so this is 12, so I have 12 squared, plus this is 9, so I have 9 squared, 15. So for this one, you'll just say TM is 15 units, whatever units they're using to measure. And then they ask a question: do these circles touch or intersect each other? Right? Do these circles touch or intersect each other? Right? And we have to what do we have to? We have to justify. Cool. So you see the point here is 3, and the point here is 3 and 2. 3 and minus 2. This one, 12 and 10, is somewhere here. So here you have a point called T, which is 12 and 10, right? And we calculated the distance from here okay, there's the center. Oh, this is M. My bad. So because this is T, so that is M. So they ask you a question, do these circles touch or intersect each other? And we must justify our answer. Remember, the distance here is what? Is 15 units. But what is the radius for the circle? Is 10, right? The radius for the circle is 10. So the radius for this circle is 10. So if I would draw, okay, let me do this. What's the radius for the circle, the smaller one? The radius is 25. No, it's 5, because square root of 25 will be 5. So the radius here is 5, ne? And the radius for this one is 10, because square root of 100 is 10, right? So if this is 5, right, then we're gonna have something like this, right? And this will be the other circle, and the distance here it's gonna have to be 10. And then 10 plus 5 makes 15, right? And therefore this will say that the two, they intersect. Not that they intersect, they do touch at a point, right? So they do touch because of this. You have 10 and 5 making 15, right? So adding the radius of the two circles gives you 15 units, which is the distance for TM. And that's how you will close this question. Just like that, man. Since the sum of the radiuses is equals to the distance TM, and then you're done, bro. You're done, and this is the end. We'll see each other in the next chapters.